Cloud characteristics and terms. If you recall, when we looked at the NIST definition of the cloud, it listed 5 essential characteristics of the cloud. In this section, we will cover the 5 essential NIST characteristics and go beyond and discuss other characteristics and terminologies that you should be aware of as a cloud computing professional. So as part of the objectives, we will look at the 5 characteristics as defined by the NIST, and then we'll look at other terms that you should know. All right, so what are the 5 cloud characteristics as defined by NIST? It's on-demand service, rapid elasticity, broad network access, shared resources, and measured service. So let's look at the 5 characteristics and then we'll go beyond. On-demand self-service. On-demand self-service is basically a do-it-yourself model. The idea here is that the cloud consumer should be able to self-provision the IT resources. All you have to do is log on, go to the cloud provider's website or use an iPhone app, and you should be able to provision your server, network, storage, whatever you want, and it would be ready to go. That's the on-demand self-service model. You really don't have to talk to anybody. It's a self-provisioning model through the various mechanisms. Like I said, you can do it using portals. You can do it using web service API. If you want, you can do that too. Mobile apps, all these different models are available for on-demand self-service. And a good cloud provider would offer you these different models. Rapid automated deployment. The idea here is that the cloud provider should make configured resources available instantly. So you as a cloud consumer go to the website, go to the portal, go use your app to provision a server. You might say, I want to have a server that's got 16 gigs of RAM, 8 cores, 1 terabyte hard drive, and within minutes, just in time, on demand, there will be rapid deployment, and within a few minutes, that server should be available. It shouldn't take months or days. It should be almost instantaneous, near real time. Some services may take an hour or two to launch. It's very rare, but it's possible. But most services are within minutes. When we talk about automated deployment of computing resources, we are talking about no human intervention. It's all automated. It's all automated in this case. Ubiquitous access. The term ubiquitous means from anywhere. The cloud service should be accessible through heterogeneous, thin or thick client platforms. You should be able to access the cloud service through your mobile phones, through your tablets, through your laptops, through your workstations, over the web, over the internet, over different protocols. That's what we mean by ubiquitous access. A cloud service should be ubiquitous access. You shouldn't really need any specialized network, any specialized hardware. Your laptop, your desktop, your mobile phones, in a coffee shop, at home, in office, no matter where you are, you should be able to have access to your cloud service. Resource pooling. Resource pooling is a concept where a cloud provider may break its resources into different pools. Pool A, Pool B, Pool C, and so on and so forth. And within each pool, the cloud provider may further divide it into different sub-pools so that the cloud provider can give these resources to the various cloud consumers. And the idea here is to create a multi-tenant model. So what you're seeing over here is one of the pools that the cloud provider has is Pool A, which contains 1, 2, 3, 4, 5, 6 virtual servers, some number of CPUs, and some amount of memory. And what the cloud provider is doing is breaking it down into 2 pools, in fact 2 sub-pools, A1 and A2, and giving 3 virtual servers to one pool, 3 servers to the other pool, and then breaking the CPU pool and breaking it down to 6 CPUs going here and 4 CPUs going over here. And in terms of memory, we have, let's say, X amounts of memory. Some amount of it is going over here to this pool, and some amount of memory is going to this pool. So the idea here is that the cloud service provider is breaking it into different pools, and within pools is breaking into different subpools so that he can provide a multi-tenant model. Now let's look at multi-tenancy. In order to understand multi-tenancy, you need to first understand the single tenant model. In the single tenant model, let's say you have a cloud service consumer A and a cloud service consumer B being customers of cloud provider. This is the cloud provider right here. For the cloud service consumer A, there is a cloud service which has an attached storage. For the cloud service B, there is a cloud service which has an attached storage. Notice they are not connected. They are separate. They are separate. This is separate from this. That would be a single tenant model. But this model may not work really well, especially if you have lots of consumers, if you have a lot of customers. So many times a cloud provider will offer a multi-tenant service model where you'll have two consumers, cloud consumer A, cloud consumer B, and they are consuming services which are being shared. For example, in this case, yes, they have their own dedicated cloud services, A and B respectively, but they're sharing the cloud storage. So that would be a multi-tenancy model, and a cloud provider may offer such a model. Elasticity. Elasticity is the ability for an infrastructure to adapt to changing capacity needs. The idea here is that you should be able to scale up or scale down to meet the demands of the consumers. There should be no need to set up servers in advance. You don't have to pre-provision any server. You just ask for it and it's available instantly. So you use what you need, when you need, and destroy it. Metering. Metering is a concept where the resource usage that is consumed by the consumer can be monitored, controlled, and reported. So a client consumer is, let's say, using 7 VMs, is using so much storage, is using so much bandwidth. All those things are being metered. The cloud provider meters all those things and then sends reports back to the cloud consumer. So this allows for transparency for both the provider and the consumer of the utilized service. And that's really the idea of metering. The idea of metering is monitoring it so that you can do chargeback. And so let's look at chargeback. Chargeback is the idea that you decentralize the IT costs and allocate them to only those who are incurring them. Even within an organization, many times you would use these servers, but it's your department that ends up getting the bill. And within your department, you may end up having different sub-projects, but they all share the same bill. What you really want to do is you want to have a chargeback mechanism which allows different departments within an IT organization get its own bill so that there's no fights. No two different departments say, oh, you know what, yes, we're using a public cloud provider and we're getting a single bill, but I didn't really use that much. You're using more. And we don't want to get into those arguments. So the idea there is that you can do chargeback and different departments can get different bills. And they allow you to do that. If you look at Amazon Web Services or the Google Cloud Platform, they do allow you to break down your bill in such a way so that you can charge back separately. There is also the pay-as-you-go or the pay-as-you-grow model. In this model, you launch servers, and as you launch servers, you pay more. As you grow, you pay more. As you shrink, you pay less. So it's a nice model. That's really the pay-as-you-go, pay-as-you-grow model, which is really connected to your chargeback, which is really connected to your metering. And now let's look at scaling. Scaling from an IT resource perspective represents the ability of an IT resource to handle increased or decreased usage demands. Now let's look at this chart over here. This is a 24-hour chart that charts the concurrent users and in the time of the day. We're starting from midnight to midnight. As you start at midnight, there's about 2,000 users, and as you can see, as the morning comes, the number of users are decreasing, and then suddenly at 7 o'clock, we have more users coming on board, and then around 2-3 o'clock, we have high amount of users coming in, and then eventually it tapers down. What we really want is a system where we are able to increase our capacity based upon the number of users or based upon the load that is happening in our system. when we want to accomplish this, we have two kind of mechanisms available. We have horizontal scaling or vertical scaling. Let's look at horizontal and vertical scaling. In horizontal scaling, the idea there is that as the load increases, you want to bring in more and more resources. So horizontal scaling is allocating or releasing of IT resources that are of the same type, and you're bringing more and more of them or shrinking them. So for example, we started with one server, which is server A, and as the demand grew, you went to two servers, that's A and B, and as the demand grew, you went to three servers, A, B, and C. And that's really your horizontal scaling. Scale up, and then you can also shrink down. That would be horizontal scaling. Vertical scaling is when you launch a server with two CPUs, but then you don't want to add more servers. What you want to do is you want to increase the capacity of that existing one server. This is quite popular for databases where you typically run databases in a single machine. So you want to go from 2 CPUs to 4 CPUs, and that would be vertical scaling. There is also this term called cloud bursting. Cloud bursting is when you have within your data center or within your premise, which could be just traditional hosting, or it could even be private cloud hosting, you have consumers that are coming in, but as the demand goes up within your data center, you basically burst out into the cloud. So the idea here is that you scale or burst out your on-premise IT resources into a cloud environment when the capacity within your on-premise environment has been reached. And for this, what you do is you redundantly deploy your resources in the cloud. As you can see in this organization, we have a private cloud and the users are coming in, they're using the service. But when the demand increases, when your internal private cloud cannot handle it, you basically use the hybrid cloud model and you burst into the cloud. That's what it's called, cloud bursting. And you burst and take the rest of the users into the cloud. So the cloud IT resources remain inactive in the cloud. You had already deployed the resources in the cloud, but they're not really being utilized, and they get utilized only when the demand increases. And then after the load slows down, the cloud IT resources that are over here in the cloud are then shut down. And so you burst back in. So the idea there is you burst out into the cloud when your demand goes up within your premise, and then you burst in. This is very common when you do hybrid cloud computing. Here what I'm showing you is cloud bursting in action. As you can see over here, this is the cloud consumer's environment. In the cloud consumer environment, he has a service. Service consumers are coming in, and as these service consumers are coming in, it's not able to handle the load, but then you have something called the automated scaling listener that is watching the cloud consumer and the cloud service. What it does is, once it finds out that there are too many consumers that are coming on board, it simply goes to the cloud provider and launches a service. And so now when the third consumer comes in, notice that the third consumer is being shifted over to the cloud service. This is your cloud service right here. The point is you have service within your premise, you have service within the cloud that's pre-deployed, and when you're not able to handle the users, you simply forward the request to the cloud. That's cloud bursting. There is also resiliency. Resiliency is a feature of the cloud where it's really handling failures. So it's a form of failover mechanism. What you really want to do is that you want to have redundant services, redundant IT services across several physical servers and several physical locations, so that when a server goes down or when a data center goes down, your services are still available. So the idea here is that you would deploy your services within multiple data centers within the same cloud provider, or you would deploy it across cloud providers. So what you're seeing here is resiliency in action. You have cloud provider A, you have cloud provider B. Within cloud provider A, there is cloud service A. Within cloud provider B, there is cloud service A. And what the cloud consumer has done is that he has used both the providers and put these services available in both the providers, in both the clouds. So when the cloud consumer uses the service, and for some reason, if the service goes down, the cloud consumer can actually go to the service that's available in the other cloud provider. That's the idea behind resiliency. In summary, we learned that the NIST 800-145 document discusses 5 essential characteristics for the cloud, which are on-demand service, which is the do-it-yourself model, rapid automated deployment, ubiquitous access it from anywhere, resource pooling, the mechanism by which cloud providers break their resources into different pools and subpools so that they can do multi-tenancy. That's the model where you're sharing the resources. We also learned about elasticity. We learned about metering, chargeback, pay as you grow or pay as you go model. We also learned about vertical and scaling and horizontal scaling that is available through the cloud. And we learned about hybrid model where you can also do cloud bursting, where you can burst into the cloud when your internal services are not able to handle it. And finally, we also talked about resiliency.